All right, today we are diving deep into the world of oil and gas. We're going to uncover a totally invisible process that honestly prevents catastrophes and keeps our entire energy infrastructure safe.
So let me ask you a question. What do you think is the single biggest threat to something massive and complex like a pipeline or a refinery? You might think a hurricane, maybe human error. Well, the real danger is actually way, way smaller and a whole lot harder to spot. Yup, the biggest threat is an enemy you can't even see, a leak. Just a tiny, sometimes microscopic flaw in a massive system that can lead to absolutely disastrous results. And believe me, the stakes could not be higher. When you've got a system designed to carry flammable hydrocarbons, even the smallest little breach isn't just a problem. It's basically a ticking clock. Now, what's fascinating is how one single leak creates a whole cascade of problems. If the gas leaks out, it can mix with the air and create an explosive cocktail. But if air leaks in, the oxygen gets inside and starts causing corrosion, basically eating away at the pipe from the inside. It's just a recipe for environmental disaster and, worst case scenario, a complete system failure. So, how in the world do you find this invisible enemy hiding inside thousands of feet of steel? Well, you send in a detective, one that can sweep through the entire system without causing any trouble itself. And for this job, there's no better detective than nitrogen. And here's exactly why nitrogen is the perfect candidate. It's got superpowers. First, it's inert, which means it's chemically lazy. It won't react with anything, especially leftover hydrocarbons. It's also super dry, so there's no risk of causing rust. And crucially, it's non-flammable. In fact, it pushes oxygen out of the way, which actually makes the system safer during the test. Best of all, it's literally everywhere. It makes up 78% of the air we're breathing right now. So our nitrogen detective doesn't just have one trick up its sleeve, it's got a whole toolkit. Let's take a look at the three main ways engineers use it to hunt for those invisible clues. First up, we've got the most fundamental method, the pressure drop test. The easiest way to think about this is like pumping up a bicycle tire, leaving it overnight, and checking it in the morning to see if it's gone flat. It's the exact same idea, just on a much, much bigger scale. And when I say bigger scale, I am not kidding. For some of these high-pressure tests, they fill the system with nitrogen to over 200 bar. To put that into perspective for you, that is nearly 100 times the pressure you'd find in a typical car tire. It's immense. So the process itself is pretty straightforward. The engineers seal everything off, pump in the nitrogen, and then they just watch the pressure gauge, sometimes for a full 24 hours. If that pressure stays rock solid, great, the system is tight. But if it drops more than a tiny, acceptable little bit, say 1 or 2%, they know they've got a leak somewhere. Okay, but knowing you have a leak is one thing. Knowing where it is, that's the real trick. To pinpoint the exact spot, engineers get a little more hands-on with what's called the bubble test. I love this one because it's so beautifully simple. The system is put under some pressure, and then a technician goes around and sprays a soap solution on all the joints, flanges, and connections. The logic is simple. If nitrogen is escaping, it's going to create bubbles in the soap. See a bubble? You found your leak. That's it. All right, now we're getting into the really high-tech stuff. For the most critical systems where even the slightest microleak is totally unacceptable, they bring out the big guns, the sniffer test. This method uses this really clever cocktail of gases. The system is filled with about 95% nitrogen. That's our safe carrier gas. But they mix in about 5% of helium. Now, why helium? Because helium atoms are incredibly tiny. They're like the Houdini of gases, able to escape through microscopic cracks that even nitrogen can't squeeze through. An engineer then uses this super sensitive detector, literally called a sniffer, and scans the entire outside of the system. This machine is tuned to detect nothing but those tiny escaping helium atoms. And the precision here is it's mind-boggling. It can find a leak so small, it's like losing a single thimbleful of air over an entire century. It's a flaw that is completely invisible to any other method out there. Okay, so we've seen the methods, but what does a test actually look like on the ground? Well, it's a very carefully planned 6-step procedure where safety is, without a doubt, the #1 priority at every single stage. The whole thing is incredibly methodical. First, they prepare and isolate the system. Then they set up all the nitrogen gear. Now this next part, pressurization, is absolutely critical. They don't just blast it with pressure. They ramp it up slowly, in stages. 25%, hold. 50%, hold, and so on, to avoid putting any sudden stress on the system. After letting the gas temperature settle down, the actual inspection begins with one of those methods we just talked about. And finally, just as carefully, they bring the pressure back down and vent the nitrogen safely back into the atmosphere.
So after seeing all of this, you might be wondering, why is nitrogen the undisputed champion for this job? Well, it becomes incredibly obvious when you stack it up against the alternatives. This table really says it all. You could test with water, that's called hydrotesting, but that introduces moisture, which can cause rust and means you have a massive drying job afterwards. Or you could use compressed air. It's cheap, sure, but it is incredibly dangerous. Mix air with any leftover hydrocarbons in that pipe, and you have literally created a bomb waiting to go off. Nitrogen is the only one that checks all the boxes. It's dry, it's inert, and it's genuinely safe for these environments.
So the next time you think about the massive, complex infrastructure that powers our modern world, just remember the unseen guardian that's always at work. It's not just about the steel and the engineering, it's also about an invisible, inert gas being used with incredible precision to find the flaws we can't see, making sure everything keeps flowing safely.